All right, so section 9.3 is actually called Connecting Graphs and Rational Equations. I'm going to title it Solving Rational Equations because that's really what we're doing. You know characteristics of a graph. You know how to find x-intercepts and y-intercepts. You know how to find the vertical asymptotes and the gap discontinuities. That's what we've been studying so far in this chapter. So you know a lot about these rational equations and their graphs. Today we're going to focus on solving rational equations. So we're going to do it algebraically as well as graphically. So if you should have a graphing calculator with you. I will use mine up here on the screen as well, so you can see what's going on. But if we think about other equations where we have solved, okay, the whole solving thing means that we're finding a value or values for x, right? So solving means that we're finding a value or values for. All right, so we're finding values for x. That's what solving means. So if we have a rational equation, I'll show you how to do that algebraically, and graphically it's just the same as we've done with other functions, okay? And that is you either find the x-intercepts as solutions to the corresponding graph, or you find an intersection point between two equations. And so let's begin. So this is example one in your textbook, page 459, if you're following along. What we want to do is solve for x. So again, what you want to look at is we notice that x is in this term and x is in this term. And we can't just simply add these together because x is in the denominator here. That's what makes this a rational equation. And so what do we do with that? Well, we have to get all of this out of the denominator of this term. We have to get x out of the denominator so that we can, combine like terms a little bit later. So what you might want to do to simplify things is to maybe get this rational part all on one side of the equation by itself. So if we do that, this turns into 6 over x plus 2. And on this side, we're going to add 5 to both sides. So it's going to be, a plus 5 over here. And we're going to subtract x. So it's going to be a minus x. Now, I'm just going to write the x first. It doesn't matter if you write the 5 first or the x first. It doesn't matter. But what we want to do here now is we want to get rid of the x plus 2, which is being divided. Or it's divided. It's 6 divided by x plus 2. And so it's a division. So the opposite operation would be multiplication, right? And so we do that to both sides, of course. And so what we get is we end up with 6 alone over here because that factor divides with that factor. And if we do your FOIL method, or you distribute, we're going to get negative x squared minus 2x plus 5x plus 10. Which simplifies to this, negative x squared plus 3x plus 10. So you might be saying, well, that actually doesn't help us, Mr. Maxwell, because we've still got the x in two terms, and now this is a squared, and this is to the power of 1, so we certainly can't combine them. But what you notice is that this is a quadratic, right? So we're going to have a quadratic, so you're going to be able to use either the zero product principle or the quadratic formula to solve. And of course, at this point, you kind of want 0 over here in order to use the quadratic formula. So, and I don't like the fact that this x squared is positive. So you know what I'm going to do? I'm going to bring all this stuff over to the other side of the equation. And what that's going to look like is this. We're going to have a positive x squared, because that comes over. We're going to have a minus 3x, and then we're going to subtract 10 from both sides. So it's going to be 6, positive 6 minus 10 would be what, a negative 4? We have nothing left on the other side. Okay? And so then we have two options. If you can solve this by just looking at it, by intuition, again, there's a 1 here as a coefficient. That's nice, because we're just looking for two numbers that multiply to negative 4 and add to negative 3. And can you think of those two numbers? So we put x here and x there, and then negative 4 and plus 1. Do those work? Let's see, negative 4 times 1 is negative 4. That's this one. Awesome. And then we have negative 4 plus 1, which is negative 3, and that's this one. Awesome. So yeah, that's correct. So our x values, when we let each of these equal 0, and you can do that if you need to show your work here, that's x equals 4. And x plus 1 equals 0, that's x equals negative 1. And of course, we let this equal 0 because this statement will be true when one or both of these factors are 0 themselves. So that's why we're looking for these values of x. Of course, once we get to this point, we can and should check our answers. Make sure, first of all, that we don't have any answers that are restricted. Okay, extraneous roots, so 4 and negative 1. Would 4 or negative 1 make this equal to 0? No. So these two answers are allowable. They're not restricted. So that's good. If you plug these in and do a quick test to make sure that this side of the equation equals this side, then you'll know. So if we do a quick test with 4, okay, what do we have? Just do a little check over here. We have 4 plus 6 over 6, right, because that's 4 plus 2, minus 5 equals 0. Well, that's 4 plus 1 minus 5 equals 0. That is totally true. And the other one with a negative 1, negative 1 plus 6 over 1 minus 5 equals 0. It's negative 1 plus 6 minus 5 equals 0. And that's negative 6 plus 6. That's totally true. So that's just a real quick check. You can do that in your mind too if you want. On a test or quiz, if I say show your check, that's exactly what you do. If I say just solve and verify any way you want, you can just do that in your head if you want, whatever. So that's algebraically. That's using algebra only. Notice we didn't use the graphing calculator there. But what we're going to do is we're going to work on the exact same question, and we're going to do it graphically just to make sure that we got the right answer, A, and to show you how to do it graphically. So anybody have any questions about this? What we just did here? So yeah, I would agree with you. If you want to include the non-permissible value every time, you certainly can. These are the two solutions. This is the non-permissible value. Some questions will ask you to state the non-permissible value, some won't. If it says just solve, yeah, just solve, and then it's up to you to check whether either one of the solutions are restricted. That's up to you then. So that's why they say when they're teaching you this, or when we're first learning this, write down the non-permissible values, so that when you get to your answer, you can just check to see if that number is permissible or not. Because some students forget to check, and they say, hey, there's two answers when one of them really is restricted. So, yeah. At this point, if it just says solve, you just can make sure that it's not a restricted value. If it is, you reject it. If it's not, then you've got these two answers. Good question, though. All right, so let's go to graphically. All right, let's do this same question here. Let's just copy that. Roger, roger. Put her here. Okay, and we're going to solve graphically. And we actually have two options for this. So where is the old graphing calc? Uh-oh, where'd it go? I think I shut her down. Nope. There it is. Start it back up. Yeah, that's brilliant. Okay. So there it is right here. Okay, and you have one on your desk as well. You should. So let's clear that. Get your engines rolling there. Okay. All right. So remember what we've learned in the past, that if you have an equation and you're trying to solve for it, and you're trying to do this graphically, you can treat each side of the equation, or if it's equal to 0, just this one side of the equation, you can treat it as a function, y equals. And if you do that, you find the zeros or the roots or the solutions to this corresponding function. So I don't know if you need the steps or not, but here they are. So the steps are as follows. Number 1, graph the corresponding function or functions. In this case, we're going to graph one function because this is just 0 on this side. So we're going to graph like y equals 0. That's just the x-axis. Big deal. So we're just going to graph one function. And then we're going to find the zeros. Okay? And we'll show you how to do that in a second. The second method of solving graphically would be to graph two separate functions and then find the intersection points. So you can kind of see that actually we're technically doing that even by graphing one function, because y equals 0, as I said, is just the x-axis. And so where does the x-axis intercept this graph? Well, it might be, at these points, which are the intercepts. So really it's the same thing, but I'll just break it down for you one at a time. Break it down, okay? I won't say that again. Okay. So, the graphing calculator, what? Why does it not show up here? It's supposed to show up here. Sucky. Okay. Something's wrong. All right. Right here. Okay, so the graph is, please join me, x plus, make sure you use brackets, okay, so you don't mess up your calculator or whatever. 6 divided by, and again, binomial, just use brackets, okay? Feel free to overuse the brackets, okay? So we have this single term here with the x plus 2 inside that term, so I'm going to have two sets of brackets there. Minus 5, okay? Now I'm not sure where the window is, so I'll just do zoom 6 to get a standard window there. Wow, check that out. Okay, it's kind of like a Nike Swish, except it's not. What is this part right here, though? Yeah, you Nike, the shoe company? Oh, you didn't hear about that before? Didn't know about Nike? I see you're an Adidas guy. I see that on the jacket. Okay. Adidas. Okay, so look at, what's this vertical sort of like, kind of vertical line there in the graph? What do you think that might represent? Anyone? An asymptote, yes.
But why is it like not straight?
Why is it not straight? First of all, the graphing calculator tries to show you where asymptotes are. They kind of look like lines, but it's just trying to tell you, hey, I have an asymptote here. And it'll do that for every graph. You'll see this sort of like a vertical line over the asymptote. It's not part of the graph, it's the vertical line. But this is the best way that it can do it. No, they aren't usually straight. No, they aren't. It depends on the resolution, depends on how far you're zoomed in and out. Yeah. It depends on where your window's at. So this is at -1, 2, okay? At -2, which, look at that, over here corresponds to the restricted value, and it's a value that, when simplified here, it's still in the denominator, so it's a vertical asymptote. Got it? All right. So what I'm looking for are the zeros of the function. So, second function, trace. 0 is option number 2. Now, what you have to remember is we've got to do one intercept at a time. So the calculator says left bound. Well, if you're going to look for this intercept, which that's what I'm going to look for first, I'm going to set the left boundary. And so that is, the arrow tells us that we've set this as the left boundary. And then it'll say, where's the right boundary? Just use your cursor, click, 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 and set the right boundary. And now the calculator says, shall I guess? Shall I play a game? You're going to guess where that intercept is in between those boundaries. And you say, please. And then it'll say 4, 0. That is your intercept. Guess what? X equals 4 is one possible solution. That's what that means. If I put 4 in here, all of this should equal 0 because it's an intercept. Right? It's not a restricted value, so it looks like that might be one of the answers. You go back to the calc, and you say second function trace, number 2, let's do the other intercept. So left boundary, remember you got to go to the left of the intercept here, just somewhere to the left of it. Yes, right boundary, down here, enter, -1, 0, so x equals -1 should also be an answer. And then of course you can check by inserting each